Have you ever just looked up at the sky and wondered how it all works? Well, everything from why we have day and night to the changing of the seasons is all part of this incredible cosmic dance between the sun, the earth, and the moon. It's the rhythm of our lives, and today we're going to break down the steps. First, let's just get a sense of scale here, because it's pretty wild. You see that number? 1,000,000. That's how many Earths you could cram inside the sun. No, that's not a typo. 1,000,000. It's a number so huge, it's kind of hard to even wrap your head around it. Okay, so bringing that scale a little closer to home, this feels a bit more manageable, right? You could fit about 50 of our moons inside the Earth. So while the sun is this almost unimaginable giant, our own planet is still a pretty big deal compared to its little dance partner. To really understand this whole cosmic dance, we just need to learn two basic moves. Seriously, just two. Once you get these down, everything else is going to start clicking into place. Okay, move number one is rotation. Just think of a basketball spinning on your finger or a spinning top. That's all it is. Our Earth is constantly spinning on an invisible line called an axis. And one full spin, well, that takes about 24 hours, which, you guessed it, is exactly why we have a day. And the second move is revolution. Now, this isn't about spinning in place. This is about making a journey around something else. The Earth is always revolving around the sun, and that big trip takes one full year. At the same time, our moon is doing its own little revolution around us, the Earth, finishing its loop in about a month. All right, we've got the moves down. Spinning is rotation, and orbiting is revolution. Now let's put them together and see how these two simple motions create the daily and yearly patterns that basically run our lives. So, this one is beautifully simple. As our planet does its 24-hour spin, half of it is always facing the sun. For everyone on that side, hey, it's daytime. And as the Earth keeps spinning, you're carried away from the sun and into the darkness. That's night. It's this constant, super reliable cycle. Day and night are pretty straightforward, but the seasons, they're a little bit trickier. We all know summer is hot and winter is cold, but why? What's actually happening during Earth's year-long trip that causes such a dramatic change? Now, a really common guess, and it makes a lot of sense, right, is that summer happens when the Earth is closer to the sun. But that's a total myth. It's just not true. Our distance from the sun actually stays pretty much the same all year long. So that's not the reason for the seasons. So here's the real secret, the absolute key to it all. The Earth doesn't spin straight up and down. It's tilted, always, at an angle of 23.5 degrees. So as we revolve around the sun, for part of the year, one half of the planet is tilted toward the sun, getting hit with strong direct sunlight. That's summer. Meanwhile, the other half is tilted away, getting weaker, more slanted sunlight. And yep, that's winter. It's all about the angle of the light, not the distance. Okay, let's shift gears and look at our neighbor, the moon. It seems to change its shape every night, right? But it's not random at all. It's a super predictable pattern, and it all has to do with where the moon is in its orbit around us. First things first, and this is crucial, the moon is not a light bulb. It's a big, dusty rock. The only reason we see it is because it's reflecting light from the sun. So the phases of the moon we see are really just us looking at that sunlit half from different angles as it goes around us. So as we start to see that little sliver of light get bigger and bigger each night, we call that period waxing. You can think of it like the light is waxing on, just growing and getting brighter. And I bet you can guess what the opposite is. After the moon is fully lit, we start to see less and less of it each night. We call this waning, as that light seems to fade or wane away. The whole cycle takes about 28 days, and we can break it down into 4 key moments. It starts with the new moon, when it's totally dark from our perspective. Then it waxes to the first quarter, where we see a perfect half moon. Then we get that big, beautiful full moon, and finally it wanes back to the third quarter, another half moon before starting all over again. And now for the most dramatic events in this whole cosmic performance. Eclipses. These are those rare, absolutely spectacular moments that happen when the sun, earth, and moon line up so perfectly that one of them casts a shadow on another. At its heart, that's all an eclipse is. It's a shadow play, but on a cosmic scale. One object gets in the way of the light, and another one passes right through the darkness it creates. So there are 2 main types. In a solar eclipse, the tiny moon gets between us and the sun, and its little shadow falls on just a small spot on Earth. But in a lunar eclipse, it's our massive Earth that gets in the middle, and its huge shadow completely covers the entire moon. So you might be thinking, well, if they line up every month, why don't we get an eclipse every month? And the reason is that the moon's orbit isn't perfectly flat. It's a little bit tilted. So most of the time, its shadow misses us, passing just above or just below the Earth. For an eclipse to happen, that alignment has to be absolutely perfect. And so, from our seasons to the phases of the moon, everything we experience is dictated by this precise, predictable dance of spinning, orbiting, and tilting. It all brings us to one last, really interesting question. We've seen how that 23.5-degree tilt gives us our seasons and defines our world. But what if it just wasn't there? What would a world without any tilt even be like?